each of these 4 steps heat has gone in. It may happen that heat has gone in only in one step, or it may also happen that heat has gone in multiple steps. Okay, how do you know whether heat has gone in or come out? dq equal to nc dt. N is, it is positive, C is also positive, only dt may be positive or it may be negative. If dt is positive, that means dq is also positive. That means final heat is greater than initial heat. Because dt equal to what? dt equal to T final minus T initial, and dq equal to final heat content minus initial heat content. If dt is greater than 0, then dq will also be greater than 0. That means final heat is greater than initial heat. That means heat has gone into the system. Okay, so the conclusion is, if Tf is greater than Ti, that is dt is positive, then dq is also positive, that is heat has gone into the system. Is this point clear? So first find the temperature at each of these 4 points. At the point A, at the point B, at the point C, at the point D. Temperature at A. Process AB. TA. Temperature at A. Which formula? PV equal to nRT. PV equal to nRT. P naught V naught by nR. TB. TB equal to 2P naught V naught. 2P naught V naught by nR. So clearly temperature has increased. That means heat has gone in. So heat input Q A B. Okay, now check BC. TB equal to 2P naught V naught by nR, and TC equal to 4P naught V naught by nR. 4P naught V naught by nR. Conclusion: it has gone in or come out? It has gone in because temperature is increased. Q BC. Okay, then CD. TC equal to 4P naught V naught. 4P naught V naught by nR, and TD equal to 2P naught V naught by nR. Hence our temperature has dropped, heat has come out, heat is rejected. Okay, then DA D equal to 2P naught V naught by nR, and TA P naught V naught by nR. So in this step also heat has been rejected. Heat is rejected. I will now show this in drawing. In this step, gone in. In this step, gone in. In this step, gone out. In this step also, gone out. Okay. So what will you put in the place of heat input in the cycle? Obviously, QAB plus QBC. Okay. And total work equal to area, because this is a cyclic process. Okay. So let us now calculate QAB and QBC. Del Q AB, del Q AB equal to NC dt, but C for the process AB is known to you.
Because it is a constant
volume. AB is a constant volume process. So in place of C you will put CV. Okay. So del Q AB equal to N CV dt. dt means TB minus TA. Del Q BC, del Q BC, again N to C into dt, but do you know the specific heat for the process BC? Why not? C. Calculate. But again, this is CP. Because during the process pressure remains constant. So N into Cp into dt. dt equal to Tc minus Tb. Okay. Since Cv is given, you can calculate Cp. So Cp and Cv both unknown. You will add these two. You will get the total heat input, and then you will calculate the efficiency. Okay. Equal to work done, area ABCD divided by del Q AB plus del Q BC. Another important thing that you should always be careful about is regarding the sign of the work. Sign of the work. Okay, because magnitude of work done, it will be given by area. Okay, but sign of the work, whether it is positive work or negative work, that will not be given by area. Area cannot have any negative sign. So you will have to follow the cycle in order to know whether positive work has been done or negative work has been done. Okay, work is positive if volume increases, because W equal to PdV. PdV, if volume increases, then dV is positive. Okay, so work is positive if volume increases. Do not forget this. Work is positive if volume increases, because you know what is the expression for dW equal to PdV. In physics, it is very simple to know whether positive work is done or negative work is done. Just consider the formula. The source of negative sign, possible source of negative sign is dV. dV is what? Final volume minus initial volume. If final volume is greater than initial volume, work done is positive. If final volume is less than initial volume, work done is negative. Okay, so it is very simple. In the AB, no, work done is 0. BC, volume has increased, work done is positive. DA, work done is negative. Now, which work is greater? Positive work or negative work? Under which curve is there greater area? Which curve has greater area under it? This line has greater area under it. So that means positive work is greater than negative work. Okay, so the total work is positive. Okay, is it clear? Equal to area ABCD equal to length into breadth equal to P naught into V naught N CV, अच्छा TB minus TA we have already calculated. P naught, TB minus TA. TB equal to 2 P naught V naught by NR, and P naught V naught by NR means P naught V naught by NR na, plus del Q BC N CP temperature 4 minus 2 means 2 P naught V naught by NR, so equal to 1 by CB by or R CB plus 2 CP na, equal to R CB plus 2 into CP minus CB equal to R, CP equal to CB plus R, CB plus R equal to R divided by 3 CB plus 2R equal to R divided by CB equal to 1.5 into 3 7.5 no 1.5 4.5 plus 2 6.5
R 0.15
2 by 13 calculated
0.15.
0.15. A small sphere is kept in a uniform electric field. This is the electric field, and this field is uniform, not a variable one, uniform electric field. Potential B is greater than, according to the statement, B is greater than 589 and less than 589.8 volt. Okay, you have to find the potential at a point that makes 60 degree. That means the radius vector means the radius connecting that point. The point is such that the radius passing through that point makes 60 degree with the direction of the field. Okay, so you have to find the field at this point. Okay, now potential equal to B equal to integration E dot dr negative. This is the general formula. Okay, since the field is constant, field is uniform, there is no need of going through integration and all. We'll simply write E into del r, the distance. Okay, so or E into del r into cos theta. Okay, where theta is the angle between E vector and R vector. For at this particular point, the angle between E and R is 0 degree, theta equal to 0, cos 0 is 1. So at this point, potential has maximum value V max, because cos theta is 1, cos 0, V max 589.8. Okay, and at which point is the potential minimum? We know along the direction of the field, potential decreases. No, this here the potential will be minimum, because along the direction of field, potential decreases. Along the direction of field, potential decreases. So at this point it is 589, and at this point it is 580. Here it is maximum potential B max. This is equal to 589.8. Okay, so potential at this point 589, potential at this point 589.8 in this direction. This is the direction of the field. The potential gradually decreases in this direction. You will have to find the potential at this point this angle is 60 degree, the radius is suppose r, so this distance is how much? R cos 60, r cos 60 means r by 2. Okay, so what is the difference in potential between these 2 points?
6.
If this is a potential at B, this point is B1, potential at this point is B2, so B1 minus B2, B1 minus B2 equal to E into distance, E equal to E not given, into distance is how much? R plus R by 2, E into 3R by 2. But we already know that E into since E into 2R, E into 2R is the potential difference between these 2 points, and it is equal to 589.8 minus 589 equal to 0.8. So this will give us E into R, or E into R equal to 0.4. This is 1, this is 2. From 1 and 2, from 1 and 2, B1 minus B2, B1 minus B2 equal to 0.3 into ER by 2, 3 into 0.4 by 2, 0.6 volt. So the drop in potential is 0.6 volt. So what is the potential at this point? 589.8 minus the drop, there is a drop of 0.6. So potential at this point is 589.2 volt. Potential at this point and potential at this point, they are equal because along the direction of field, the distance of these 2 points are same. Okay, so answer is 589.2 volt. This is the answer. Fact that we use. With an isosceles triangle, length of the base is L, its height is H. This is a plate. Do not think this to be a rod structure. This is not a rod structure. This is a plate, triangular lamina, isosceles. Isosceles lamina. About this axis, moment of inertia about axis through O, mass of this is suppose m by 2 into h square plus L square by 12. Okay, this can be derived, this can be proved, but I will advise you to remember it as a standard formula. Okay, do not forget that this has to be an isosceles triangular lamina. It has to be isosceles. Okay, we will apply this here. First of all, consider the given triangle. Side of the triangle is not given. Let the length of each side be L. Okay, length of each side, suppose it is L. So its moment of inertia about this axis, or that you can do, or you can do one more thing. Why not break it, split it into 3 triangles, 3 isosceles triangles, then find the moment of inertia of one triangle about this axis. Okay, and for this you can use this formula. Let the mass of this Bm, mass of this is also m, mass of this is m, so total mass is 3m. So moment of inertia, suppose this is A, B, O. So I, A, B, O about axis O equal to m by 2 h square plus l square by 12. You have to calculate the height. This is h. You can find it easily by using that 2:1. What is the length of this median? This is L. This angle is 60 degree. So this side is L cos 60 and this side is L sin 60 because this is right angle triangle. So its length is L sin 60, that is L root 3 by 2. Okay, we are interested in length of this portion. This is h. So h equal to L root 3 by 2 divided by 2 is 2 plus 1. You know, this part is 2 and this part is 1. Okay, this is the centroid. It cuts the median in the ratio 2:1. So this divided by 2 plus 1 into, we require this part multiplied by 1. This is equal to L root 3 by 6. Is it okay? L root 3 by 6. This is h. So now moment of inertia of this triangular portion of this isosceles triangular lamina about the axis O, m by 2 into h square. H is this much. H means 3 L square by 36 plus L square by 12. L is the length of one side. So this is L square by 12 equal to m by 2, ml square by 2, 3 12s are. So 1 by 12 plus 1 by 12 means 1 by 6 equal to ml square by 12. Is it okay? Okay. So this is the moment of inertia of this triangle. And you have 3 such triangles in this triangular lamina. So what is I naught? I naught is the moment of inertia of this triangular lamina about this. Hence,
So এখানে L টা বসালেন কি করে একটা সাইডে
L is this length.
হ্যাঁ কিন্তু এই দুটো সাইড তো L নয়
হ্যাঁ equilateral triangle.
না না এই মানে আমরা তো ফার্স্টে তো ওইটা ছোটটা নিচ্ছেন ওই তিনটে পার্টে ABO
This part.
হ্যাঁ
This part. What is the length of this?
ওটা তো
L.
এই দুটো সাইড তো আলাদা
Now we have calculated the moment of inertia of this part.
হ্যাঁ
Then I naught equal to I naught equal to 3 into IABU. Can we do this or not? Because these 3 are identical triangles or not? We have calculated the moment of inertia of one triangle. Other 2 triangles are identical or not? Identical. So what is the total moment of inertia about this axis? 3 into IABO equal to 3m L square by 12 equal to 4 ml square by 4 ml square by 4, or I think instead of I will write it in this step. Let it remain in this step. That will be better. 3 into ml square by 12 means 3m into L square by 12. What is the advantage? So, means what is my plan? I will use the same expression for finding the moment of inertia of DEF. See, I will use the same expression. So that means I will treat this as a formula. So what is the moment of inertia of triangular lamina about an axis through centroid? Mass of the lamina 3m, mass of the lamina into length of one side whole square by 12. So what is the moment of inertia of this portion? Again I will use this formula, mass of this lamina into length of one side whole square by 12. Okay, so it will save you lot of calculation. What is the length of one side for this? L by 2. Okay, and mass of this, take mass of this as m dash. So mass of, we have three such triangles, m dash, m dash. Okay, so IO. Now moment of inertia of DEF, I of DEF about axis through O equal to, see I am using this formula, 3m is the total mass. In that place I will write 3m dash. What is the length of one side? L by 2. So L by 2 whole square by 12 equal to now I do calculation 3. So can you write m dash in terms of m? Then your problem is over. If you can write this, because you are having already, you are getting m square by 12 here. Okay, 3 4s are m dash L square 4 4 are 16. Is it okay? M dash L square by 16. So your problem is solved. Only thing, m dash has to be written in terms of m. Okay? Can you write a relation between m dash and m? No. Simple. What is the total mass of this body? 3m. Again, what is the total mass of this body? No, in terms of m dash. Now, total mass of this body in terms of m is 3m. Again, the total mass of this body in terms of m dash. How many such triangles? This is, what is the total mass of this body? 3m dash. Now, one triangle, 2, 3, 4. 4 into 3m dash, can you write or not? What is the mass of this triangle? 3m dash. Mass of this triangle, 3m dash, 3m dash, 3m dash. 4 into 3m dash, 12m dash. And 12m dash, using m dash it is 12m dash. And in terms of m it is 3m. So can you write 3m equal to 12m dash? Mass of the body 3m. Again mass of the body 12m dash. So 3m equal to 12m dash. Something is clear? Mass of the body, first you write the mass of the body in terms of m. It is 3m. Then you write the mass of the body in terms of m dash. It is 3m dash, 3m dash, 3m dash. There are 4 identical triangles. 3m dash, 3m dash, 3m dash, 3m dash. 12m dash. Mass of the body, mass of the lamina, intact lamina. Mass of the intact lamina ABC equal to 3m equal to 12m dash. Okay, so number 1, number 2, now we'll put m dash equal to m by 4 and you will get answer. Hence IDF equal to m dash equal to m by 4 m by 4 into L square by 16 ml square by 64 equal to, now write it ml square by 64 and what is I naught? I naught is ml square by 4 ml square by 4. So ml square by 4 means I naught by 16. Can you write this? I naught equal to ml square by 4. I naught equal to ml square by 4. So ml square by 64 means ml square by 64 means ml square by 16 into 4 equal to I naught by 16. Is it okay? I naught by 16. This is the moment of inertia of this triangular of DEF. You have to find the moment of inertia of the residual. Hence, moment of inertia of residual about O equal to I naught minus I naught by 16 equal to 15 I naught by 60. This is the falling from a height h, and due to each collision 50% energy is lost. 50% energy is lost due to each collision. What is the initial energy?
mgh.
Initial energy is mgh. Okay. And first collision after the now this mgh energy it will convert into kinetic energy. Okay. So means just before the first collision energy is mgh, and this energy is in which form? In kinetic energy form. After the collision the energy mgh by 2. Okay. So mgh by 2, and to what height? And this will be in form of what? This will be in the form of kinetic energy. So the height to which it will rise, after, suppose this height is h1. Okay, we can easily calculate h1. mg at the top, at the highest position, the total energy will be potential energy, and since there is no loss of energy, means due to collision their energy is lost, but after collision there is no loss of energy. So that means mgh by 2 it will convert into mgh1. Okay, so mgh by 2 it will convert into h1, or h1 equal to h by 2. Okay, then the second collision it will fall. Okay, just before the second collision, what is this energy?
mgh by 2.
mgh by 2, mgh by 2, and after the collision, just after collision, its energy will be mgh by 4, mgh by 2, by mgh by 2, mgh by 4, mgh by 4. With this energy, it will rise to a height, suppose h2. At the highest position, the entire energy will be in potential energy form. So at the highest position, the energy is mgh2. mgh2. First, this is for first collision. First, second collision. For second collision, mg h by 4 equal to mg h2, or h2 equal to h by 4. Now consider one more collision. For the third collision, with what energy will it heat? It will heat with energy again mgh by 4, and with what energy will it rebound? mgh by 8, because half of the energy will be lost, mgh by 8, and so it will rise to a height, this time to a height h3. We can easily calculate h3. Third, for the third collision, mg H/8 equal to mgH3 or H3 equal to H/8. Okay, hence total distance covered there will be infinite number of collisions. Total distance covered S equal to H1 to H1 plus 2H2 plus 2H3, there are infinite number of collisions, equal to 2 into H/2 plus H/4 to infinite terms, 2 to cancel, H 1 plus half plus 1/4. So GP 8 into A into 1 minus R to the power n.
A by 1 minus R infinite.
Infinite series A by 1 minus R. There is direct formula and R equal to half. So equal to 2H.
So first is the
First is not counted. After that 2H.
after that.
After, we have not counted the first one. If you count the first one, then H plus 2H 3H, but it is not there in option. So obviously you have to calculate the total distance travel after the first collision. So problem should clearly state now. In competitive exam, the students are already under tension, and to find the acceleration of this block, first indicate tension in the spring. Okay, then write equation for the suspended mass. For the suspended mass, the forces are mg downward, T upward. So the equation is mg minus T equal to mass into acceleration. For the wheel, for the pulley, the force acting on the pulley is, which force is acting on the pulley? Tension T, not mg. Mass is not connected to the pulley, it is the string which is connected to the pulley. So which tangential force is acting on the pulley? Tension T. Tension T. So T is acting on this and it will rotate in this direction. So for rotation, the formula is tau equal to I into alpha. Who will exert torque? T will exert torque. That means T into R. I into alpha. This is a disc. Moment of inertia is about its own axis. mr square by 2. Alpha. A by R. Cancel. Or T equal to MA by 2. First equation, second equation. Just put T and get it. From 1 and 2, from equations 1 and 2, mg minus ma by 2, ma or A equal to 2mg by m plus m by 2. 2m. Man is located at the equator in this direction. Force acting is W in this direction in non-inertial frame. Centrifugal force will act m omega square r. Okay, and in this direction also normal force will act. Normal force is actually the weight of the man. So for equilibrium of the man, for equilibrium of the person n plus m omega square r equal to W, or n equal to W minus m omega square r, according to the problem, n, weight of the man, is given as 3W by 4. 3W by 4, W minus or m omega square r equal to W minus means W by 4 or omega square equal to W by 4mr, okay, equal to, what is m? This in absence of rotation. In absence of rotation, suppose the earth is not rotating, in that case the weight is W, that means W equal to m into g. W equal to m into g. So m equal to W equal to g by 4r. So omega square equal to g by 4r, or omega equal to root over g by 4r. Put the values, 6,400 kilometer. So multiplied by 1000 meter, 10 cancelled, equal to 1 by 2 into 100 into 8 equal to 1 by 1600, okay, equal to 1000 by 1600 into 10 to the power minus 3 equal to 0.6 something into 10 to the power minus 3. So we'll solve this type of problem in CGS. That is most important about it, because water equivalent, by water equivalent we understand M into C. Water equivalent of calorimeter means M into C of calorimeter, and this is valid only in CGS. So 0.025 kg means 25 gram. That means M into C of calorimeter is 25 gram. Okay. So in order to use this fact that M into C of calorimeter is 25 gram, we use CGS to solve the problem. We'll get our answer in calorie and we'll convert that into joule per kg degree centigrade. So heat lost equal to heat gained. Heat lost by aluminium sphere equal to heat gained by calorimeter plus water. Calorimeter plus water. Okay. Or heat lost by aluminium sphere. Mass of the aluminium sphere is 200. 200 into C. Change in temperature 150 degrees centigrade to 40 degrees centigrade. So 150 minus 40, heat gained by calorimeter, M into C of calorimeter, and its temperature rises from 27 to 40. 40 minus 27, this is of calorimeter, plus heat gained by water. Mass of water is 150, we are using CGS, into change in temperature 40 minus 27, or 200 into C into 0, 110 equal to m into c, 25 gram into 13 plus 150 into 13, or c equal to 175 into 13 divided by 200 into 110 35 into 13, and this is in
gram degree Celsius.
calorie per gram degree centigrade. We now convert it into joule per kg degree centigrade. It is given 1 calorie equal to 4.2 joule. 1 calorie equal to 4.2 joule. So 35 into 13 by 200 into 22 into 4.2 joule in place of gram. We will have to convert gram into kg also. 1 gram equal to 1000 kg equal to 35 into 13 into 4.2 into 1000 by 200 into 22. Equal to 35 into 13 into 21 by 24.3 joule per kg degree